3.3 polynomial and synthetic division. So just a little reminder of long division. If I want to try to divide this by 3, now some of you might be able to do this in your head, and that is great. But let's go over what long division kind of looks like. First, you always want to match up this first one. So like I can fit a 1, 3 into that. So I'm going to have 1, 3. However, because this is in the hundreds place, that would actually be 100. And then I subtract. So now I have 12 or 100, 280. Now I think, oh, now I can look at these first two because 3 can't go into 1, but 3 can go into 12. That would be times 4. So 3 times 4, but this, now I'm adding 1, 0. So that would be that. So now what I have over, I always subtract these. What I have left over is this 8. And I have to think, okay, well, 2 threes can fit there. That would be 6. And if I subtract that, I get 2. So if I were to write out this final answer, I'm adding my 100 plus my 40 plus my 2 plus the 2 that is left over that I divided by 3. My overall answer for this is 142 and 2/3. This is the same thing we're going to be doing, but with our long division for polynomials. So first I'm looking at my 6x minus 19x squared, 6x cubed minus 19x squared plus 16x minus 4. I personally, if there's no term written for a degree, I always write a 0 in. And I'm dividing by x minus 2. What we always want to do is we want to see what should we multiply this leading coefficient by so it exactly matches this. In this case, I need to multiply x by 6, and I need 2 more x's, so x squared. So you're taking that, and there x minus 2. And if I were to multiply that out, this becomes 6x cubed. This right here, if I multiply that in, this becomes a minus 12x squared. Again, the hardest thing that people always forget, you are subtracting this. So you are changing these two terms. You are subtracting it. So what I have now is now these two cancel. That's good. Now 19 plus 12 would give me a 7x squared. And both this 16x and this 4 are left over. So what do I multiply x by to get the 7? I would need a 7. I have 1x, but I need 2. So I have to multiply that x minus 2 by the 7x. 7x times x is 7x squared. This becomes minus 14x. Again, you're subtracting this whole polynomial. So subtraction means you're switching the signs. So my 7x squared cancels. Now I'm left with a 30x and a minus 4. So the x is already matched, but I need this 30 here. So times that x minus 2, looks like I'm going to have a remainder. This becomes 30x squared minus 60. Again, you're subtracting. This is the biggest one, subtracting. The 30s cancel, leaving me with a positive 56. So my final answer is all the things that I got to match. So the 6x squared plus 7x plus 30 plus my remainder always has to go over what I'm dividing by. So right here is my final answer. I want you to try to solve this second one by yourself. And you should have got 3x squared plus 4x minus 7. Now the difference between these, whenever you have a remainder, that means that this right here, this polynomial is not a factor. However, with this x plus 4, that means that's a factor of this polynomial. Another way to think about this is that I could take this x plus 4 out, and I could rewrite this one as x plus 4 times 3x squared plus 4x minus 7 if I wanted, because this is a factor, because I get this 0 at the end. This also means that this right here of this polynomial, because this is a factor, that means a 0 is at negative 4. Remember, it's always opposite of this, because this is where it crosses the x-axis. This means at negative 4, this would go through the x-axis. Now, one thing you have to be always careful about is when I don't have all the degrees written. So I have this x minus 1, and I want to divide the x cubed. I'm going to have a 0x squared, because there's no x squared in this problem, I'm going to have a 0x, and I'm going to have this minus 1. Now, sometimes it's going to work out where I don't actually need those zeros, but it's still going to be the same concept. So if I multiply this by x squared, because I need 2 more x's, I would get an x cubed right here. And then if I multiply that by that x squared, I get minus x squared. Notice how I need to have that there so that when I subtract this, I'm actually going to get a positive x squared right here. And now I'm going to have that plus 0x minus 1. You have to make sure you have each degree represented. So now if I look, what do I have to multiply that x by? I need to multiply it by x. This becomes x squared times negative 1. Now again, I subtracting that, changing both signs. So this becomes an x minus 1. And right here, I don't need to multiply it by anything. So essentially, I just need to multiply it by 1. So I have this x minus 1, and I'm subtracting, bing, bada, boom, and I get 0. So again, my answer here would be x squared plus x plus 1. This is usually for this problem where people go wrong, is for getting that 1 at the end. I want you to pause the video and try to do B by yourself. And you should have got this. Now, another thing, a reminder. I can also synthetically divide. Remember, because there's no leading coefficient with this x, what I can do to synthetically divide is we take the 0 of the function that you're dividing by. So in this case, it's 1. It's a positive 1. We put that positive 1 in a box. And then we put all of our leading coefficients here. So we have a 1 in front of the x cubed. We have a 0 in front of the x squared. We have a 0 in front of the x, and we have a minus 1. Now, to synthetically divide, you always bring down your leading coefficient. So always bring down that one number. You multiply by this box number. So 1 times 1 is 1. And you add up and down. So you add up and down, and then you multiply to get across. So 1 times 1 is 1. You add up and down, multiply. Again, I get a 0. Now, what we actually did there is we took out a degree. So this was x cubed. We took out a degree, leaving with this x squared. Then each number after that represents 1 degree lower. So this answer is x squared plus 1x plus 1. Again, what we got, just the same thing as up here. I want you to try to synthetically divide this. And again, you should have gotten the same answer that we had above. You don't have to write these ones there, but you sure can if you want to. So I want you to try to do this one right here by yourself. I'm going to help you set up the box. So you should have the negative 3 in the box because it's always the opposite. Again, we have 1 for x to the 4th. We have negative 10. Nope, just kidding. We don't have an x cubed here, so we need to have x to the 4th, x cubed, x squared, our x, and our number. So I want you to synthetically divide that right now. So again, this was x to the 4th. We're taking out a degree. When we divide, we take out a degree. This is not a factor. There's not a 0 here. So my final answer here would look like this. X cubed minus 3x squared, because we're taking, once we know our leading degree, it's 1 below that each time, minus 1x plus 1, and then this right here is my remainder. I have 1 over, I'm dividing by the x plus 3, so 1 over x plus 3. Pause the video and try to do B from start to finish by yourself. You should have gotten 5x squared minus 2x plus 3. And this last page that we're going to do that in class. So there you go. Have a great, have a grand, have a wonderful day.